All right, guys, here is example 2 for 10.2. Find the vertex, the focus, the directrix of each parabola and graph it by hand. So it's going to be, I want to make sure that I am writing down all of the things they are looking for. So first, it wants us to find the vertex, find the focus, find the directrix, big D, and of each parabola, and then graph it by hand. All right, so these are all of the things that we are supposed to answer. So 2a, quantity y plus 2 square equals -4 times x minus 3. Because your y variable is being square, so we know that it'll either open to the right or the left, and this is negative, so we know for sure that it opens to the left. Okay. We have a few things we can find right away. First thing is we are going to find the vertex. The vertex is going to be your h comma k. So h is going to be 3 and your k is going to be -2. Next, we need to find an a value so that way we can locate the focus and the directrix. So a, it's going to be 4a, or -4a equals to -4. Or you can think of it as an absolute value of those. Since it's an absolute value, it comes out to be 4a equals to 4. A comes out to be a 1 unit. If it's 1 unit, we know that from the vertex to the focus is 1 unit, and from the vertex to the directrix is also 1 unit apart. So best thing for us to do right now is plot it out. Let me make some grids. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. Vertex is at 3, up 3, -2. So 3 down 2, label it V. We know that it opened to the left, so the focus is going to be over here. I can find that location right away. That's 2, comma, -2. The directrix is 1 unit, aka a unit. So here's directrix. X equals to 4. X equals to 4. Okay. If we know those three, we now need to find the total length of your lattice rectum. Length of, and it's always an absolute value for A. Absolute value for A happened to be an absolute value of 4, which is 4 units total. Okay, if I know it's 4 units total, I can go up 2 from the focus and down 2 from the focus to finish graphing by hand. And remember, I may ask you to find the location of the lattice rectum, so might as well get used to labeling these. This is 2, comma, 0, and then this is going to be 2, comma, 1, 2, 3, 4, -4. Okay, so those are them. We graphed it by hand, checked. We found the vertex, the focus, and the directrix of each parabola. Example 2b, very similar, except that we need to complete the square. Ready? To complete the square, we first will factor out the 2. We know the y variable is being square, so we know it either open to the left or to the right. So y squared plus something, I'm sorry, not plus something yet, plus 6y plus something blank equals -x plus 1. We do not need to complete the square for the x because we don't need to factor that out. Half of 6 is 3, 3 squared is 9. I mean, we're going to add 9 over here, but that 9 is really being multiplied by 2, so this is really 9 times 2. This is now then factor out as a y plus 3 quantity square equals to -x. 1 plus 18 is really now 19 plus 19. And then we're going to get rid of this 2 in the front very soon. But before I do that, I want to factor out a -1 So that means I have x minus 19. To get rid of this 2 in the front, I'm going to multiply that by a half. What I do to that side, I do to this side. Here is our equation. Y plus 3 squared equals negative 1/2 times x minus 19. This is our equation. Okay. Now I need to answer the parts that they want. Vertex, focus, and directrix. Here we go. Vertex, focus, and directrix. Vertex is always h comma k. So here's h and here's k. So that's going to be 19 comma negative 3. Ooh. Okay, well, I'm definitely not going to do 19 take marks. So for the x location, I will just do every 5 units. 5, 10, 15, extend this all the way out, 20, and 25. And the y-axis, I can stick it 1, 2, 3, 4, 5, 6, 7. Okay. So vertex is negative 19 comma 3. So it's right here. Eyeball 19. Sometimes 19 comma negative 3. So here is your V. Next, I need to find an A value for us to even find the focus and the directrix. Are you ready? A value, well, we know that it opens to the left because of the negative 1/2. See this right here? We are going to take negative 1/2. We're going to set it goes to negative 4a. To get rid of negative 4, we will multiply this by negative 1/4. Negative 1/4. So a will come out to be, ooh, super tiny, isn't it? A is 1/8. Oh my. So that means we are going to eyeball 1/8. So the focus, we know it opens left. So the focus is somewhere here on this left side, and it's going to be super close to the vertex. This is just 1/8. So what does that mean? I'm going to take the x-coordinate of the vertex and minus 1/8. So the x-coordinate of the vertex was 19. So 19 minus 1/8 comma negative 3 is the new order pair of the focus. Take away 1/8 is 18 and 7/8 comma negative 3. This is your focus. That gets filled in right here. 18 and 7/8 comma negative 3. And we're going to do the same thing to the directrix. The directrix is 1/8 behind the vertex. So that means it's going to be an x equals 19 plus 1/8, which is really 19 and 1/8. I'm going to try my best to graph out our directrix. I'm not going to hold you for this particular approximation. Okay, there you go. So that's going to be x equals 19 and 1/8. I need now to know find the length of the latus rectum, so I know how far up to go. Length of latus rectum, which is an absolute value of 4a, which we already know an absolute value of 1/2. Well, the total length is 1/2. That means you're going to go up 1/4 and down a 1/4. I'm going to see if I can fit 1/4 in here. 1/4 from, remember, you're going 1/4 from the focus. So here's 1/2, here's 1/4. I'm just going to eyeball this. This is going to be 1 skinny, okay, 1 skinny according to my grid. I went up 1/4 and I went down 1/4 from the focus as best as I can make 1/4. Then if I ask you to find the order pairs of the latus rectum, we can take the y value of the focus and we add 1/4, and we can also take the y value and we subtract 1/4. And remember, the reason we do 1/4 is because it's half of the total length. So if I ask you to find the latus rectum point on the top here, then we're going to take remember, the y value of the focus. So the x value should be exactly the same. The y value is -3, and we're going to add a quarter. Of course, we simplify. So 18 and 7/8, comma, -2 and 3/4 is the top piece of that. We could also do the same thing on the bottom. I'm going to use different color. It's going to be x coordinate is the same, 18 and 7/8. And we're going to take the -3, which is the y coordinate of the focus, and we subtract a quarter. So this final answer for this bottom order pair for the lattice rectangle is 18 and 7/8, comma, -3 and a quarter. So if I ask you for the order pairs, those are the two order pairs if it's ever asked, and that's how we find them. Example 3 of 10.2, write an equation for the parabola. First, if you look at this parabola, we know it opens up, so right away I would write the equation out, so by the time you are asked to take an exam, it's already in your memory, okay? And let's identify the vertex. Let's see, this vertex is 1, comma, -4, so I can fill that in right away. Your h is 1, your k is -4. So x minus 1 squared equals 4 times a y minus and -4. Two negatives will make it now a positive. Well, if I can find a, then I would be good. Well, to find a, you can pick any point that's nicely, well, not all the time that I'm going to give you the dots, but if it's any point that you have not used. Since I've already used the vertex, I can't use again. But my favorite point is when one of it is 0, so I will use 3, 0. So x is 3 minus 1 squared equals 4 times a. Y is going to be 0 plus 4. This is going to be 3 minus 1 is 2. 2 squared is 4 equals 4a times 4. That's 4 equals 16a. To get rid of 16, we are going to multiply by 1/16 or divide both sides by 16. This will give us a 4/16, which is a quarter. So your a, it's a quarter. Then all we have to do is plug it back in. Final answer is going to be x minus 1 quantity squared equals 4 times 1/4 times y plus 4. Yes, you must always simplify. So final answer is 1 minus x minus 1 squared equals 4 times a quarter is 1, which you technically don't need to write the 1 in the front. Yes, you may, but you don't have to. And this is as far as you need to go. And this example 4 of section 10.2. A searchlight is shaped like a parabolic of revolution. So a paraboloid, it's just a parabolic shape, okay? So it's a parabola shape of revolution. So just fancy for in terms of parabola. If the light source is located 2 feet, so this is what I want you guys to know right here. Light source is located 2 feet from the base along the axis of symmetry, and the opening is 5 feet across. How deep should the searchlight be? So a searchlight is in essence a flashlight. And a flashlight, I'm going to try my best to draw it for you, okay? Here's sort of and there's a light bulb somewhere in the bottom, and we have light source. So that's a light source. Now the light source is the focus from the base. So if I make the base we're going to make the base at the origin because it's just the easiest location. So the base is at the origin, 0, 0, which is your vertex, okay, which is your h, k. So when the base or the vertex is at the origin, h and k will always be 0, 0. Now the word light source, this is where the focus is. They gave it to us. The focus is right now at 0, 2. The reason I know 0, 2 is because this is a parabola opening upward. And then they even went further and said, okay, well,
The opening is 5 feet across. So this is 5 feet across. What that means is that I know this order pair. This order pair is 2.5 feet, comma, some y value. And this order pair is negative 2.5 feet, comma, some y value. And again, when you can, always try to put the vertex at the origin. So now what is it looking for? It says, how deep should the searchlight be? How deep means I'm looking for the height of this searchlight. I'm looking for the height means I'm looking for the y value. Since it opens up and the vertex, so let's put it back into the formula of a parabola. Opens up meaning that your formula is x minus h quantity square equals to 4a times y minus k. Well, h and k are both 0 because the vertex is at 0, so x squared equals 4a times y, since k is also 0. If I can find y, then that would be my answer. Well, I do know x. X is, according to this, x is 2.5 when y is unknown. I can definitely plug that in. So 2.5 is really 5 over 2 quantity squared equals 4. Well, I have one equation and 3 variables. I know what x is. I can plug that in. A, so let's remember, A is the distance from vertex to focus, okay, or vertex to the directrix. So remember that. Since we have the focus, A happens to be 2 feet. So plug that in and we're solving for y. So 5 over 2 squared, that's going to give me 25 over 4 equals 8y. To get rid of 8, we will multiply both sides by 1/8. 1 over 8. And y now comes out to be 25 over 32 feet. So how the deep, okay, the searchlight is is 25 over 32 feet deep. When you can, I do prefer the simplest exact answer. All right, and that's it. That's all we're looking for. And again, on your homework, I may be asking for the focus, which is where the light source is located, or I may be asking why the light source is, or anything like that. So just understand the whole concept so you know what to do. And this is the end of example 4.